In today's video, we are going to be using the exponent laws with terms including variables and numbers out in front. So in this problem right here, we have two terms being multiplied, 4x to the third and 5x to the sixth. And we're going to use the exponent laws that we've learned previously and apply them to these algebraic situations. So first, we needed to get the terminology down. These numbers out in front are called coefficients, right? So whenever you see a number in front of a variable, those are called coefficients. So 4 and 5 are my coefficients. X is my base. 3 and 6 are my exponents. So when I refer to these, it's going to be important you know the names of these when we're using these laws. So when I multiply two terms like this, what I do is I multiply the coefficients together. So you get 4 times 5. Keep the base, right? This is x and x. And we are going to add the exponents, 3 and 6. 3 plus 6. So we multiply the numbers out in front, keep the base, add the exponents. Now we simplify. 4 times 5 is 20. X to the 3 plus 6, which is 9. So it's 20x to the ninth power. Okay, let's look at another one. We'll use a different letter with this one. And we'll make this a 4. Okay. So when we have a division problem like this, well, a fraction, right? A fraction means to divide. What we do is we divide the numbers out in front. And subtract the exponents, right? Well, first let's divide. 30 divided by 6 is 5. And we subtract the exponents. So this exponent is 4. This exponent is invisible, 1. So it's y to the 4 minus 1, which is 5y to the third. Okay, sometimes we might get a scenario where we have negatives. So let's take a look at that. Let's do let's do 2, and we'll make this 5/3. And we'll have x and to the 4th and x to the negative 10th. So we have a multiplication scenario here. So again, we multiply 2 times 5/3. And when you multiply 2 times 5/3, that is 10/3. Keep the base, add the exponents. So 4 plus negative 10. Now simplify. Can't simplify 10/3. So we're just going to leave it 10/3. x to the negative 6 power. Now, we have a negative exponent, and what we're going to do when we have a negative is we're going to bury it to the bottom of the fraction in order to make it positive. So whenever you have a negative exponent and a problem asks you to write it with only positive exponents, we need to take this term here and put it with the 3 in the denominator. So my final answer would be 10 over 3x to the 6th. And positive because I had to put it under the fraction mark. I had to put it under along with the 3. So whenever you have a negative exponent, you bury it to the bottom of the fraction. Okay. Let's take a look at another scenario. All right. Okay. So this one a little bit different than the division one we did before. We have a fraction here. 45 doesn't go into 12, but I can reduce this fraction. I can simplify it. When you simplify it, either you doing it in your head, using a calculator, you reduce the fraction, right? Both have a common factor of 3, right? So when you divide both of these by 3, you get 4 over 15. So when you simplify that, you get 4 over 15. Now, be careful when you subtract the terms with the like bases, right? Negative 3 minus negative 2 is negative 1. Negative 3 minus negative 2 is the same thing as 3, do this different color, plus 2, right? Negative 3 plus 2 is negative 1. Now, this is a negative exponent, so it would then go to the bottom of my fraction, and you have 4 and over 15 to the x power. And that's it. Now, again, if this was positive, you would just leave it where it is, all right? Or bring it to the top, okay? But since it's a negative, you got to bring it to the bottom. So we took a look at multiplying, we took a look at dividing. One more scenario I want to show you. Let's do 3. We'll change this letter up to Y. All right, in this scenario, I threw in a 2 here, right? So I threw in a 2 outside of the parentheses. Now, if you take a look at this, don't you do a power to a power? Okay, I'll show you why I don't recommend doing a power to a power with this. You'll see why. Okay, what I suggest doing first is expanding this. Okay, what do I mean by expanding that? If I take this base to the second power, you can expand it to 3y to the 6th, 3y to the 6th, since there is 2 of them. And then I bring the other one down, 5y to the 4th. And then you use the laws of multiplication. You remember, you multiply the coefficients. You multiply the numbers out in front. So 3 times 5 is 45. And you add the exponents, right? 6 plus 6 plus 4 is 12 plus 4, which is 16. Now, since this is a positive exponent, it doesn't have to get buried. It doesn't have to be put underneath in the denominator. So this would be my final simplified answer. Now, to go back to why did I not just do 6 times 2 is 12? All right, so let's do that here. Do that on the side over here. So if I did this, right, and I multiplied the 6 times 2, you would get 3y to the 12th multiplied by 5y to the 4th. Okay. Now, when I multiply 3 times 5, that's 15. And when I add the exponents, that does give me 16, but that is not the same answer over here. This is 45y to the 16th. This is 15y to the 16th. So what's different, right? Well, first of all, the number out in front. So how do we get the number out in front? We did 3 times 5. But over here, you notice there's 2 3s. So that's because this exponent has to get reverse distributed to both exponents out in front. So really, this is a 3 squared y to the 12th. Then 3 squared times 5 is 45, right? When I multiply these two together, 3 squared, which is 9, times 5, which is 45. Then I add the exponents, and I get y to the 16th. Okay, so there's multiple ways to do these, but I like seeing the expanded out version. Now, if it was a ridiculous number like 20 up here, it would be a lot to expand that. But with a simple number, it's kind of just easier to see it all expanded. Then you multiply the numbers in front, add the exponents. All right, so that's it for today's video. Thank you for watching. And always remember, whether you solve for X or Y, always give math a try.